Hello, my dear students. Another session about the general properties of metallic or metals in the first transition series elements. Okay, so three metallic property. As we see, as we know, all the metals is characterized by general characters. These metals or these elements in the first transition series is metal. Okay, all of them are metals, so they are characterized by the general properties of all metals. The all metals having metallic cluster means shining, reflect the images on them like this brightness. They are composed their surfaces have metallic cluster. Okay, good conductors of electricity and heat. These are general properties. Here they have high melting point and boiling point. Why? Because the 4s and 3d electrons shares in the metallic bond, as we have discussed the last session. So here the melting point of all of these metals, scandium, titanium, vanadium, and all the metal elements in the first transition series have very high melting point. The highest of them is chromium, 1890. The lowest of them is copper, which is 1083. Here manganese in group 7b supposed to have a high melting point, as its electrons which share in the metallic bond is higher than chromium 4s1 and 3d5. Here manganese 4s2 and 3d5, chromium 6 valence electrons and manganese 7 valence electrons. But in case of manganese, the attraction force between the 4s electrons, the two 4s electrons, and the 5 electrons in the 3d is very high in case of manganese, so they do not participate properly in formation of metallic bond. So in general, the melting point is higher than 1000. So if the question states that there is a metal or there is a substance which its melting point is lower than 1000, it is not from the transition elements. Okay, so about the densities also, the densities increases as we go from left to right. From left to right, the atomic mass increases and the volume is nearly constant. We know that the density equals mass divided by volume. So when the volume is constant, when the mass increase, as the mass increase, so the density increase. Density starts from scandium 3.1 gram per cubic centimeter and ends with copper 8.9, from 3 to 9. So less than 3, it is not considered as a transition element. So also we'll speak about the variation in their chemical activity. There are some elements in the main transition metals or the main transition element series which has high activity in point of chemistry, in chemistry point of view. So like scandium, it can replace the hydrogen of water very vigorously. Iron, moderate activity, and copper, limited activity. It is not inert, but less activity than iron, which is moderate, less active than scandium, which is high active. So we'll speak about some examples here on application about these concepts concerning the main transition elements. So which of the following represents the properties of a transition element? Density, melting point, and boiling point. As we have said that the melting point should exceed 1000. So when it is not exceeding 1000, it is not correct. So the correct choice here is D. Look here at the density. Density starts from 3.1 and till 9 gram per cubic centimeter. So these are correct, but here it is the only one which refers to the melting point which exceeds 1000. So the correct answer here is D. The correct answer here is D. Let's have another example. Here, the following graphical figures represent the graduation of three properties of the transition elements. Okay, and a question is, which of the following states the property whose graduation is represented by each of the three graphical figures? So here, a property decreases until chromium and nearly constant in the chromium, then increases gradually after that in zinc. So this is atomic radius. Okay, atomic radius, the first graphical figure is atomic radius, yes, so it is not the third. So this appears to be the atomic radius. So 1 is the atomic radius 100%. So 2 and 3 is wrong options. So here it is graduation of effective nuclear property and graduation of the highest common oxidation state. Now highest oxidation state, as we have explained before, it increases from scandium, which is positive 3, 1, 2, 3, to manganese, which is 7, and decreases to positive 3 and positive 3 in cobalt, nickel positive 2, and copper positive 2, and zinc positive 2 also. So this property appears to be the highest oxidation state. The highest oxidation state supposed to be the third diagram. So 1 is wrong and 2 is wrong. So here it is the first, yes. Let's check if the second is the effective nuclear charge. Yes, it increases from scandium to zinc without any exceptions. So the correct one here is the A option. Okay, let's have another example if there is. Okay, magnetic property. We'll speak about the magnetic property the next session.